Hello all, welcome to the web application pen testing series at Pentester Academy. Now in the last video we looked at CSRF basics, and now what we want to look at is how the industry goes about preventing CSRF attacks using different security methodologies. So the one we are going to take up in this video is CSRF prevention using tokens. Now, before we get into what tokens are and how they work, the core thing we need to understand is what is the problem that we are really trying to solve in the case of CSRF. Now, the problem seems to be that the browser automatically sends the cookie with every request to a web server, right? And the advantage for the attacker is that if he creates a malicious page with a link for a third-party website and the user is logged into the third-party website, then the cookie gets sent automatically and the attacker does not need to know or predict the value of the cookie in advance. Now, unfortunately, in the absence of any other session or operation validation, CSRF would always work perfectly, right? Now, the question arises, the only way the third-party website can actually figure out that a CSRF attack is going on is if it can somehow figure out that the user is logged in and using the website, or is he not, right? In the case he's using the site, of course he should be allowed, and the case he's not, then his request should be denied. Now, as you can imagine, this is a totally non-trivial problem. Now, one of the attempts at solving this is using tokens. Now, what are tokens? Really long random values which accompany every session or maybe even every request, and ideally should not be repeated for the entire application's lifetime, right? So how do we go about using these totally random tokens? Now, the way developers implement token protection to mitigate CSRF is first to identify all the critical operations in an application. Now, by this we mean the different URLs where GET, POST requests are hitting, API endpoints and whatnot, right? Now, for every such critical operation, the application expects that the request must accompany the token, right? The token must accompany the request, right? Now, given the fact that this token is long, random, unpredictable, and is delivered as part of the HTML, maybe in the case of GET, it could be part of the URL. In the case of POST, it could be delivered as hidden fields in the form. So basically, because this is delivered as part of the HTML for the logged in user, it is impossible for an attacker to know the value of the tokens in advance. Now keep in mind that if the application changes token pretty much for every request, it's almost an impossible task for the attacker to ever manage to do anything. And this is the rationale behind using tokens to protect against CSRF attacks. Now, let me explain this with a quick illustration. So in the first case, we are going to take user interaction without using tokens. So here is a regular web user. Here is an e-commerce website. And typically, the e-commerce website is going to send out, let's say, the purchase HTML form to the user's request. The user then fills up the form, hits the submit button, and the browser submits the form data, let's say over a post request, and cookies and other session state, etc., travel to the e-commerce website. Now, of course, if this is truly the logged in user, the cookie and whatever is required in the form matches what the site expects, the transaction goes through. Now, how does an attacker go ahead and exploit this? Well, the attacker is going to lure the victim basically to visit his site. So this is the attacker control site. And in that site, he's going to go ahead and probably have an image link or a script link or an iframe link to a GET request to the website, or maybe a form which is going to make a post request to the e-commerce website. Now, when the user visits the attacker controlled site, his browser automatically ends up sending the post form data along with the cached cookie for the e-commerce website. Now, from the e-commerce website standpoint, it receives all the data it requires, pretty much identical to what the real user had sent, and hence it happily accepts and the operation goes through. Now, let's try and understand what happens when we use tokens. Now, this time around, when the user makes a request to the e-commerce website for viewing a specific URL, let's say which contains a purchase form, the website sends him back the HTML page with the form. However, now in the form, typically as a hidden field, there is the CSRF token value created either per session or even per request. Again, the per session versus per request is really the choice of the developer, right? And hence, when you audit web applications, you might see a huge variation of the best practice being used. Anyway, so now the user receives the HTML page with the form and the token as a hidden field, right? So now when the user fills up all his data and submits it, the form data travels along with this unique token with cookie and other session data, right? Now the website receives this, validates the token value, right? The token validation has to happen to what the website expected. And if that validation succeeds, the website happily accepts the request and goes through with whatever operation the user is requesting, which could be purchase of goods, adding a new credit card, or whatever the user might have requested. Now, in the case of the attacker trying to do the same thing, as you can imagine, it is impossible. Here is why. The user is going to visit the attacker's website. Unfortunately, the attacker has no way of figuring out what would be the token which would be served as part of the HTML form to the user. He has no clue, right? Neither can he force the user's browser to go ahead and make a request, get the token and send it to the attacker, right? In the typical case, it just isn't possible. Hence, the attacker will not be able to create an HTML form with the correct token as the hidden field. And hence, when, let's assume, the attacker creates the form, unfortunately doesn't have the token value in there, and the request goes through to the e-commerce site, the e-commerce site now does not find the token in there and pretty much rejects the request, right? So if you notice in this entire schema, the success of the CSRF prevention depends on this token being completely secret and something the attacker can never predict or obtain. So let me show you an example of how this token looks like. I'm going to use the OWASP WebGoat application just like we've used before in previous videos. So this time around, I'm going to go to XSS and then click on CSRF token bypass. right? You can read through the lesson. This is similar to the last two lessons we've done. An extra parameter transfer funds equals main needs to be added. So before that, let's quickly get the URL in question. Hit an enter. Here is the URL. You want to copy this one out. And let's actually minimize this a little bit. And now, did I hit the right one? Hold on. Let's clear this real quick and have a look. Seems like an old lesson. Yeah, my mistake. I'm sorry. I need to click on the token bypass, right? This one in here. This is it. So if I hit this URL, at the end I need to append a transfer funds equal main, right? I'm going to do that. I'm going to append that value in there, and now hit an enter. Now if you notice, this time around we again get presented with an electronic transfer. However, if I look at the source code of this form, let's actually do a inspect element. You would actually find a CSRF token value in here. Can you see that? The value of the token seems to be -10621 blah blah blah, right? Now if I refresh the page, which is make a fresh request, do you notice the value of the CSRF token changes in here? There you go, right? Right now it became 758 blah blah blah. If I refresh this again, you notice it changes again and again, right? Pretty much unpredictable if you keep watching this value. Now I'm not going to go into any token analysis, which is, you know, how robust is the token, is there enough entropy, enough randomness. This is similar to analyzing the session state value, which we've taken up in many previous challenges. I'm probably going to give out one or more challenges on CSRF token analysis. So keep watching the web application challenges section, and you're probably going to find one or more of them, which you can play with. Anyway, the point in this case is, now if you were an attacker and you had to go ahead and create a post for this form, you would unfortunately never know the value of the CSRF token which was assigned to the user at that point. And hence, you can never create a custom request through your attacker controlled website. And even if you lure the user to visit your site, you would never have the right token, and hence the website would always deny your request. So this is really how CSRF tokens work. Now, of course, this isn't a foolproof mechanism, right? What could possibly go wrong? Now, as I mentioned earlier, the most important thing is the token value should at no cost and no time be predictable, right? So is the token long enough? Because if it isn't, someone could brute force it. Is it random enough? Because if it isn't, someone could predict the algorithm for how the token was derived. And, you know, really bad development practices include deriving the token from known predictable data, right? Now, apart from the token itself being long, random, and unpredictable, is the token repeated or reused? This is again a really bad idea. Is the token stored securely, right? Keep in mind that if the token is part of the URL parameter for a GET, then, you know, your history in your browser, server logs, and many other places basically might contain the token. Now, apart from this, is the token going to be transmitted over a secure medium? Is it HTTPS? Because if it isn't, then keep in mind that the transit could be something you'd worry about, with the possibility of sniffing and MITM attacks, depending on how your end user plans to connect to your website, right? Is he using a hotel Wi-Fi? Is he using some sort of a public municipal Wi-Fi? Depending on all of that. So these are important. As I mentioned in the challenges section, we will take up some of them. Now, apart from this, as far as CSRF goes, I would highly recommend looking at the OWASP CSRF guides. They are very elaborate, and a lot of stuff we discussed are based on those guides. So have a look, read through them. I'm sure you're going to learn a lot of smaller things, given the level of detail to which the authors have gone. Fantastic. So hope this video was enjoyable. And if you did, please recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you.